Learning and knowing mathematics as a software engineer nowadays considered as nice to have thing for regular software engineer, but it is vastly underestimated how important that can be in certain situations when you develop the even basic components of your web application. Here is the story to prove my point that happened to me back in the days. Long time ago, I decided to create my first software product, which was the online knowledge testing tool that determines whether the company employees have the enough knowledge gap to work for that company. And that time I built the UI with React and Node.js and also the Fancy Websockets to essentially give the real-time communication feel for the web application. But it turned out the most important part that relies in app functionality, that of course the math part, where I had to calculate whether the score matches the way the users wanted to pass the tests or not, and overall statistics, how they went through all of the questions within a test. It turned out I had to learn a lot to be able to create that math equations, and of course that changed how I view the product itself and what components I needed to deliver to backend from my UI. So I ended up rewriting a lot of components that supposed to be just written once, and that ended up being huge redundant work. Now, looking back, I actually regret that at some point in my university studies, I haven't paid that much attention to the math itself, and I just learned to pass exams and not specifically focusing on math components as a software engineer, because that supposedly I was becoming to be from the university. So not knowing the math basics itself, it took for me more time actually to write that math equations than building the web application itself. And I could have easily avoided all of that if I just kind of studied enough and knew the concepts that I needed to have all of that calculations and statistical analysis to be able to write that algorithm from first hand, or even imagine what could be requirements to have that algorithm in place. Nowadays, there is a ton of libraries that you can use to create math-related products or calculate statistics or pretty much anything that you can imagine related to math. Even using the standard Python NumPy library gives you so much power, and you don't need as much math knowledge as it have been required in the past. But at the same time, it comes down to the things that you have to know what is going to be required in order to create a specific algorithm and use existing ones to provide more efficiency, because usually it stands down if you don't know what type of things you will need. It will make your life a lot harder to understand where to find them. This is why pretty much all of the large IT companies require you the mathematic focus, the algorithmic tests, or general software optimization skills in order to pass the interview stages. That defines how much problem solving capabilities you have as a software engineer, because being a software engineer is not only about coding per se, but also solving specific problems, and having the math knowledge just makes it so much easier to think about problem solving and not only about coding for a specific task, because you can do the coding and writing a code, but problem solving is not something that can be usually optimized or automated. So that's the part of the software engineer that really distinguishes from the AI code generator tools. There are several important reasons why it is very important to learn math, before actually joining and building software products for large-scale use cases. First of all, math helps to think logically and solve problems. That's the most important part of software engineering job, and coding is just a time-consuming thing that you just have to perform, and at some point it might be even automated, but the problem-solving part will remain still your job as a software engineer. And of course, math helps you to think logically and make the right decisions based on the logical thinking perspective, rather than having just things that you know and versus things that you don't know. Because if you think logically, there are ways that you can discover things that you don't know but actually turned out to be true. Secondly, math helps you to understand the complex algorithms, and of course helps you to write your own algorithms to optimize your software product, and helps you to understand existing software product schemas and how they are optimized. The optimization part is quite important, especially for large IT companies and the products that going to face a big performance bottleneck. It is probably not for every single product, and majority of companies or products never even come too close to any performance bottlenecks, and usually tools that are already pre-built with the optimized way and optimization algorithm in place, they are work pretty fine without any custom logic tweaking. But of course, there is some specific part that when you come across to a specific task that requires optimization, then you might just regret that you haven't knew that type of things upwards. There is a notion that as a software engineer, you need to learn math to understand algorithms and to pass the job interviews, and then that's it. That's true for about 80% of use cases, but when you hit the wall and you need to optimize the software or write your own algorithm, at that moment, that might separate you as a software engineer from all of the majority part of software engineers who don't know the math and don't know the optimization algorithms. And you as a software engineer might become more valuable to the company and to the community itself if you know, for example, how to write better optimized code, or how to structure your code base that looks and works better in majority of cases. So if you are serious about becoming a successful software engineer and you picked up your direction in the right way, then that is very good pace to learn math at the same time, or learn generic algorithms or how optimization works in general. That might put you in completely different position compared to other software engineers who might be good at coding, but they might just hit the wall when there is a time to write an actual structured, optimized software product. Hope this helps you to be a better software engineer, and in any case, just write in the comments what you want to learn and what type of things you are interested in. And don't forget to hit that like button. That will help me appear in more people's timeline.